All right, in this video we are going to integrate by parts utilizing, or what Dr. Adamson calls 1952 math. So we are going to be doing problem 5, and problem 5 is you're finding the indefinite integral of x ln of x dx. So to utilize 1952 math, which is integration by parts, we are going to let u equal x dx. Or in this case, sorry, we're going to let u equal ln of x. Why? Because if we were to find the antiderivative of ln of x, that's kind of hard. You would have to just memorize the number in order to find the antiderivative. So for this case, we'll let this and this be the antiderivative, and we'll let u, be ln of x. So we get ln of x. Now we have to find the antiderivative of ln of x. So we get du over dx equals 1 over x, or in this case, du equals 1 over x dx, because we multiplied across. Great. Now we have to find dv, but we have dv equal x dx. That's what we're saying as we integrate by parts. So what are we finding when we do that? Well, we have to find the antiderivative. What's the antiderivative? We are going to say that it is 1/2 x squared. Because you add 1, bring the 1 forward, you add 1 to the x, which gives us 2, bring it forward, and then of course you do the inverse operation because it's not there in the original function. So we have our du, our u, our dv, and our v. What does that all mean though? Well, that's derived from an equation which we said is u times, and I'll see if you guys can see right there, dv equals u times v minus v du. This is a big deal simply because this is the equation for integration by parts, or in this case 1952 math. So great, what do we do? Well, we found our derivative of u, and we found the antiderivative for dv. All we're going to do is we're going to substitute now. So as we substitute, we're saying that ln of x times dv, which we said was x dx, is equal to ln of x, because we have it right there, times v, which we said was 1/2 x squared, minus the integrand. We'll put the integrand right there, but the integral of v, which we said was 1/2 x squared times 1 over x dx. So that's what we have. Now, the overall goal of this is to try to get rid of the dx. So how are we going to do that? Well, first of all, we could cancel out the x, which essentially would leave us with, if I were to only write this portion, because this portion is equivalent to the right side of the portion. But if I were to write it out, we would get ln of x times 1/2 minus x dx. Great, so we have that, but we still have the dx. We got rid of the x at the 1 over x, but it's still there. We still have the 1 there, and we canceled it with the x squared, so we have x. But we could still go further beyond that. We can simplify more, basically, if you will, with the dx. We have to get rid of it. So that gives us with ln of x times 1 over half x squared minus. Now, since we're minusing and we're getting rid of dx, we technically don't have to write the integrand anymore. But basically, we were finding the antiderivative with dx. So that would give us 1/4 x squared, because you're adding 1, bringing it forward, inversing, multiplying, so you get 1 over 4th. And that's how you get that. But wait, there's more. Gotta add our constant variable right there. And that alone should allow us to calculate the indefinite integral utilizing integration by parts, or 1952 math.